That was a really good day of tennis.
I'm so glad I won.
Yeah, I'm not very good at tennis. What I am good at is tennis jokes. I'd like to hear one.
I'd love to hear a tennis
Alright.
joke.
What time does Sean Connery go to Wimbledon?
Sean Connery, James Bond, Austin Martin, Carver on 1 o'clock.
Actually, tennis, twins, tennis.
Oh,
Yeah,
tennis! Yeah, I get it because he can't say tennis properly.
That's really rude, Wayne. That's not. You should not take into account his feelings. That's.
Oh, you're right. I'm going to take this moment. I'm sorry, Sean. Okay, I'm sorry.
We accept his apology, and with his apology, we're going to bring Impulse.
Yep, so subscribe to us.
Yep. So, Impulse, another new word for A2 physics.
Yep, and it's actually defined, it's one of those things that's defined with the equation.
Yeah.
So impulse is equal
to the force times the time that the force acted upon.
Yeah. So Ft or
Yeah.
delta Ft, the change in the force over time.
Yeah.
And what we also know, this isn't part of the definition, that will be your definition.
That is
Yeah,
the definition.
you'd explain what F and T is equal to as usual.
Yeah.
Delta Ft equals the change in momentum.
So then, if you know the change in momentum, you can then work out your impulse, or vice versa. So if you don't know how to do stuff about momentum, we just did a video on it.
Yep.
So you can check that out.
Yep. And the momentum stuff is going to happen over time, so you can easily work out the force. So, for example, a tennis racket. You hit a tennis ball, it's coming at you at a speed.
Yeah.
You hit it, it's probably going to go off even quicker.
Yeah.
And it's going to hit the tennis racket. It's going to be in contact with the tennis racket, which is when the force is applied.
Yeah, for
a set time.
And you can work out the
the
time
force
all the time. Yeah.
And in general, you can work out the impulse on the ball as it's in contact with the racket.
Often in your exams, you'll have to work these things out from graphs.
Yeah, and it's going to be force against time graphs.
Yeah.
So force of a y and time on your x.
So it's relatively obvious what's going to happen here.
Yep, you should know. F times t is your impulse.
Yeah. So it would just be the area under the graph.
Because you find out your area by doing F times t. In this case, it's a curve.
Yeah. So it'd be, you have to integrate it, but you won't have to do anything like that. It would be a shape. You might have to make a few assumptions, like a rocky shape, and make squares or rectangles and triangles.
So it might be.
It might not be perfectly accurate.
I don't know what this would be for, but it might be something like.
Yeah.
You know, that. I don't know. I'm just sort of making this up to that point.
Yes.
So you'd have to divide that up, as Triv said.
Yeah, into shapes that you know how to work the area of. So you could do, yeah.
I mean, it wouldn't be that big, and I don't know what that would be for, but you'd get a force time graph and you'd have to work out the area for impulse.
But that's relatively simple as long as you understand what it's meant by that.
So this was a really quick video on quite a new thing.
Yeah.
Next video we're going to elastic and inelastic collisions.
Yeah, which is more about momentum, and impulse might come in there as well.
Yeah, impulse might pop up quite a lot, but just remember your graphs, your equation, and how to define it.
Yeah.
Remember, I'm better at tennis, you're better at tennis jokes. And Sean Connery, I really am sorry, it's just a joke, you know?
It's James Bond, man, just leave it out.
You can make fun of me,